how can a strong STEM foundation open doors for civil engineers that might be able to get involved in emerging fields like energy storage and infrastructure resilience and things of that nature?
Engineering is actually open to an entire variety of personality types. You can be the person who sits behind the computer designing really cool, cutting edge, innovative pieces. Or you can take this very rigorous way of thinking, which is something I love about engineering, and you can go forward and you can help sell the idea, right? Because engineers, there's a portion of us.
Did you know that nearly 50% of college students who start in a STEM major switch to another field or drop out entirely? With engineering and technical fields in high demand, what truly separates those who struggle from those who thrive? In this episode, I'm joined by Scyller Borglum, PhD, Vice President of Underground Storage and Energy at WSP USA, an accomplished petroleum and geological engineer, and the author of STEM Study Habits. Scyller is going to talk about what it really takes to succeed in STEM and why underground storage is shaping the future of energy and how engineers can build the right habits for long-term career success. Join us as we explore her journey, the strategies behind effective learning, and how a strong STEM foundation can open doors in fields like energy storage and infrastructure resilience. The projects that she works on are absolutely mind-blowing. I'm your host, Anthony Fasano, and this is the Civil Engineering Podcast. All right, now I'd like to welcome our guest onto the show for today. Scyller Borglum is a PhD, Vice President of Underground Storage and Energy at WSP USA. She's also an author of the book STEM Study Habits. Scyller, welcome to the Civil Engineering Podcast.
Thank you. Excited to be here. Thank you, Anthony.
So, Scyller, why don't we start off by telling our audience a little bit about yourself, kind of what sparked your interest in petroleum and geological engineering, and how that journey led you to your role as VP of Underground Storage and Energy at WSP USA.
Sure. So my background is a little bit different. It took me a while to figure out what I wanted to be and how to get there. Those are two completely different questions. So I started off as a business major, international business major, and I minored in Norwegian, Scandinavian studies. That gave me the opportunity to go study in Norway on a Fulbright scholarship, which is where I frankly was introduced to the energy industry as we knew it in the late 90s. So it was Norsk Hydro and Statoil. They were the Norwegian energy and oil development companies. Well, I didn't have an engineering background, but I absolutely loved everything having to do with energy and its role in, frankly, moving civilization forward. I came back to the United States. It took me a little bit to figure out how to get there. I went through a master's program for theology and had considered doing something along the lines of biblical ecology, but I didn't really see a career path in that other than maybe a hobby. And so I got out and worked for a while because you need to work to pay for your student loans. And I did for 5 years pharmaceutical sales. I enjoyed it, but I knew that wasn't my lifetime calling. I really wanted to get into energy. And over the course of these years, I thought I would be a lawyer because that's what we do in America. We go to law school. I think we have one lawyer for every 300 people in this country. Well, I didn't get into the law schools that I wanted to. So I got into some good ones, but not the ones particularly for energy. And so as I talk about in my book a little bit, finally a girlfriend, I'm sure she was totally exasperated with me and tired of listening to me. She said, "Why don't you just go be a petroleum engineer?" And I said, "Because I don't know what that is. I had never heard of this. I didn't know that this is what people did." And when you grow up in the energy industry or with family, then this is abundantly clear. But for those of us who are outside of it, it's this impenetrable, inscrutable world that you have no idea how to get in or what to do. So at 32, I went back and earned my master's of petroleum engineering. And I loved it so much. I wanted to go the distance. And for those who are in this work, there's the fluid, and then there's the rock, and there's different interfaces that you can study. And I was interested in that. At the time, I was living in North Dakota, and the shale boom was happening. So I started my PhD in geological engineering, and then the oil boom busted. So I went back to Rapid City, which is where I was at South Dakota School of Mines, and thought, well, if I'm going to stay here, because I ended up meeting the man that I would marry and his life is here. South Dakota is the one state in the area that has no commercially producible petroleum. So then I thought, well, I might need to be a consultant. And so I then called up Montana Tech and I said, how many classes away from a bachelor's degree am I? Because to earn your PE, of course, you need an accredited bachelor's degree. And so, if you do this, if you take these and you bring in this for professional work, it turned out it was just one semester's worth of courses. But I had to start that January because my other credits would start expiring that I hadn't used yet. So I said, okay, I will be there in January. So for one semester, then I commuted back and forth between Rapid City, South Dakota, and Butte, Montana, earned my second bachelor's degree at that point, came back, finished my doctorate. And so for somebody who swore up and down that she was only going to earn a bachelor's of business, I ended up with 5 post-secondary degrees. 3 of them are in engineering. And
A partridge in a pear tree. Wow,
that's
I know you're
exactly right.
edgy.
And so
Yeah.
yes, I am the example that parents use of, if you're gonna do this, then do it right. Otherwise, just get out and get a job.
Well, I mean, I also think though it is a testament to the idea that at any point in your career you can make a change and you can change gears, shift gears, if you will, and try something different. And I know a lot of our listeners are practicing civil engineers or professionals in the infrastructure industry, but I also know that a lot of them are thinking about their children and if they want to become engineers and what they might do. And so I think that it's always important to remember that at any point in time, you can go back to school and it's not too late. And there are a lot of different exciting things in the industry. And we're going to get into underground energy storage here today with Scyller, but we're also going to talk about STEM and a little bit of what she's learned through her journey with her book and stuff, which I think is all interesting for the future and the future of our industry. So I'm excited to kind of dive in. So let's start with your book, STEM Study Habits. It focuses on helping students succeed in STEM fields. What
Yes.
inspired you to write it, and who is this book primarily for?
Great questions. And the reason I wrote this book is because this is the book I was looking for when I went back to school. And if I could put out to your audience and reiterate what you just said, it's not just about the kids of engineers going back to school. It would be, we are so desperately short of STEM professionals in this country that if you are in your 30s or your 40s or your 50s and you think you want to go back to school to be an engineer or a STEM professional, you are the reason I wrote this book, because I had been out of high school at that point for 15 years. And that was the last time I'd done any math or science. Now I was good at it and I enjoyed it, but it had never occurred to me that I could be an engineer. When I was graduating from high school, which was in 95, the guidance counselor asked me, "Do you want to go into nursing or teaching?" And I said, "Well, neither." And not because there's anything wrong with that. My grandmother was a nurse, a very good one. My great grandmother was a fabulous teacher and special ed teacher, but I knew those weren't the right fit for me. And I don't think, I hope that we're not still just putting women into those two pathways. Still, I hope we're now saying, if you are interested, go. We need nurses and teachers, but if you're interested in engineering, go do that. Well, so then in my research, I'm sad to say now it looks like men are not going for 4-year degrees as much as they used to. And so this book isn't just for women, and it's not just for non-traditional students. It's now hopefully for everybody who might be interested at all in a STEM degree. So whether it's a pure science degree, a mathematics degree, some sort of technology or engineering, we need we need everybody. And so this book that I poured my heart and soul into is really the accumulation of having mentored and tutored students all the way through. That was one of my side hustles that I would do is tutor fellow students, not because they needed me to really explain how to do the math or the science. Sometimes that was the case. But honestly, Anthony, the biggest hiccup that I found for students, whether they were foreign students coming into the United States or American students, was they just didn't have study habits. They didn't know that you need to go to class every single day. You cannot be skipping class and just depend on somebody to give you their notes because you have no idea what they missed in their notes. You have to plan to do your homework every single day. And as you can imagine, students who come out and they're comparatively bright, you probably didn't have to study that hard in high school. And now all of a sudden, you've got all this, what looks like open time in your schedule in a traditional course load, right? And
Right.
those blank spots in your calendar need to be filled up with study time for your homework. And then as I moved forward, I real in coaching students and helping them get onto the graduation portion, realized that a lot of them are not prepared to put together a resume. How do you dress for an interview? What kinds of scholarships are available after college? If do you want to go in the military? Do you want to go on to grad school? Do you want to go in the professional world? And so I created this handbook really for anybody, whether you're a high school student and you want to go into a STEM degree, or if you're like me and you're going back to school at 32 and your study skills are a bit rusty, if not completely absent, how do you do that and be successful without burning through 5 years to try and get there?
Hmm. Yeah, it's really interesting. And, it's amazing some of the things we take for granted. Like you said, show up for class, certain kind of study habits, which is things that are really important. I mean, to me, we've done a lot of career coaching here at EMI and training for leaders in the industry. And we're always talking about establishing good habits and healthy habits, right? Because you can go to a training course, but then you can walk out and never remember anything. But if you take it one step at a time, show up to class every day, show up to work every day, build the right habits, that makes a difference. And I think a couple things you said that were really important there is I think one of the challenges, which is obviously a whole nother podcast episode, though, is the price of education today, right?
Yes.
Like you said, less males are going for 4-year education. And I know my son right now is in high school and we're talking to him about it. And the price of education is like you can go to a tech school for 18 months and have a great career in like a tech field, like an HVAC tech, and save yourself a couple $100,000. Now, I'm not saying that's the right way to go, but what I'm saying is that those are the options today that people are up against, which makes it difficult, which is definitely a challenge. And you also mentioned the military. I went to a college fair with my son, and I happened to start talking to the Marines recruiter there. And, you know, please vet me on this because I'm not, don't like hold me to what he was saying. But what he was saying to me was that if you enlist in the Marines, after 2 years, you have enough credits for an associate's degree. And I never knew that.
I didn't know. Yeah.
That's very interesting to me. So my point is that there are a lot of options today, which makes this a little bit more challenging. But I think going back to one of the first things you said that I think is really important is not putting women in certain buckets when they come out of college. Like you said, maybe way back when there was assumptions made that we shouldn't be making. Now I know we've gotten better at this. My wife's a civil engineer too, so we talk about this from time to time, but everybody has access to engineering. And I think more people that are prominent in the industry that have degrees and credentials like yourself that get out there and talk about it is going to be helpful. And I think the other thing that we need to do is we need to let kids know how exciting engineering is, right?
Absolutely. Yes.
That's a big part of this. My mom was a math teacher. She's retired now, but I used to go to her class with a civil engineering activity, like design this site and lay it out, and the kids loved it, right? But like I don't think anyone ever exposed them to that, and they just heard of engineering as like the math and the sciences and not really knowing the engineering piece of it. So, I think people like yourself that are writing books, sharing stories and getting out there is what we need to do more of. And that's important. And that kind of leads me kind of right into my next question for you, which is STEM education is often seen as an investment in the future. And from your perspective, how can a strong STEM foundation open doors for civil engineers that might be able to get involved in emerging fields like energy storage and infrastructure resilience and things of that nature?
So from my perspective, an engineering degree, whether you do one of the more, and please don't be insulted, but one of the more general engineering degrees like a civil or a mechanical, right? Those are, I think, two of the largest engineering programs in the United States. Those make you those make you employable in any number of fields and can be translatable, whether it's robotics, whether it's the energy, as you said, surface facilities, infrastructure, all all incredible work that goes to what I think is building up our civilization. And so for me, when I look at, I just came back from a vacation in Belize with my husband, and those ruins were occupied, some of those areas were occupied for 3 millennia. And you think about, it's a feat of engineering, and it was useful to humans for 3,000 years. And what kinds of projects are we building on and involved in right now in this country or around the world that's going to be around for 3 millennia, right? That's mind-blowing. And so to me, the most exciting thing about being an engineer and taking on that big investment is knowing that it's not just one personality type, right? I was in sales for a long time. I had a political career. I enjoyed being out there meeting people. I also know myself well enough to know I'm never going to design the world's greatest well bore. That's just not who I am. But there may be a petroleum engineer sitting right next to me who does, and he or she would be very, very good at it. So I think it's critical, as you said, to go out and emphasize with people, men and women, traditional and non-traditional, and say engineering is actually open to an entire variety of personality types. You can be the person who sits behind the computer designing really cool, cutting edge, innovative pieces. Or you can take this very rigorous way of thinking, which is something I love about engineering, and you can go forward and you can help sell the idea, right? Because engineers, there's a portion of us who need to be able to speak to the general population, speak to policymakers, speak to leaders of companies so that these projects can get funded and go forward for the betterment of civilization. So for me, that's one of the most exciting pieces about this big investment in my education.
Yeah, I agree. I mean, I think you can't go wrong investing in your education. And what I always tell people is, if you're going to to college, or maybe your children, if you're listening and you're a practicing engineer, and they're up in the air between, hey, I might want to get into finance, I might want to get into engineering. Well, if you get an engineering degree, you can go work in finance.
Absolutely.
If you get a finance degree, you can't go become a professional engineer. So,
Yes.
I mean, you have to go back
But you have to
though
go
and do
back to
some more
school,
work,
right?
right? So my point being is, my road finance companies wanted to hire me after I graduated with an engineering degree. They were like, "Oh, we'll teach you everything you need
Yeah.
to know because your brain is working analytically." So again, if you have any inkling into engineering when you're an undergraduate, consider trying to get through it, because there are still other things you can do, whether it's engineering or science or other areas with your engineering degree, that may be beneficial. And I think, to the point of energy storage and infrastructure that we're going to get into, is even if you have a degree in one type of engineering, it's likely you can go into a lot
Yes.
of different fields of engineering with that degree. Yeah, maybe you have to take some classes and get educated technically on some things, but there will be a lot of doors open to you. And I say this probably almost on every episode, is that there will be jobs for civil engineers tomorrow that don't exist today, right? With
Absolutely.
all the AI and and everything that's happening in infrastructure. So I just think the bottom line here is that your STEM education can open up a lot of doors for you, and you don't even see what they are today, but
Exactly.
that investment that you're making can really pay off in the long term.
One thing I'd like to add to your comment is when you talk about if you're vacillating between engineering and finance, which I agree with you completely, go for engineering because they can teach you the finance when you get there. What I like to encourage students to do, especially if they're going on to graduate school, is don't pay for a graduate degree in something that you can go learn yourself, right? Pay for a graduate degree, make that investment in something that you would honestly not go do on your own or by yourself or have the ability to do by yourself. And the reason is because why pay 50, 80, $1,000, $80,000 for something that you could go to a library and learn, right? But
Right.
I never would have been able to understand petroleum engineering on my own, no matter how much I went to the library. And so for me, it was worth it to write out the big checks, go pay for the degree and get the degree, earn the degree, because that isn't something I would have done on my own. So that's
Right.
very similar to what you said, slightly different nuance. So if you're going to pay for the degree, make sure it's something you're not going to have done all by yourself or capable of doing all by yourself.
Right. You're not going to go sit in a coffee shop for a couple hours a week and become a petroleum
No.
engineer. So, yeah, that's a good point. So, the other thing I wanted to ask you is a lot of students believe that they kind of need to be naturally gifted in math and science to succeed in STEM or engineering fields. How does your book kind of challenge this idea? And what advice do you have for students that are kind of maybe struggling with these subjects but have some goals?
One of This is something that I find just completely peculiar because it really only settles on math and science. And it's this idea that if I'm not instantaneously great at it, then I'm no good at it, full stop. Well, first of all, when we were toddlers, none of us were good at walking, right? This is something that took a lot of practice. And when we took our very first steps as toddlers, we didn't go run a marathon the next day. Okay. It takes a long time for something as simple as walking to start translating into a long distance run, which, by the way, I've never actually done a full marathon, but they seem like a lot of work to me.
Yeah.
So, with math, right? People think that, well, if I don't get it just watching it on the board with the professor walking through it, or just after one problem, if I just don't get it, then I'm no good at it ever and I should just let it go. And the truth is, math, and this is what I talk about in my book, learning math is effectively learning a new language. And I didn't show up with one day of Norwegian and then expect that I could speak the language fluently. I've been studying it for years and I still struggle with it. So, with math as a language, you have to practice every single day because this isn't something that we do every single day, like walking or generally speaking English in this country or our native languages. So my recommendation is based on what I've done for practice in terms of learning a new language or learning a new skill. Count on spending about 3 hours a day in your calculus 1 course or your pre-calc course. Get to know that thing inside and out. Doesn't mean you need an A, doesn't mean you need to have 100% on your quizzes or your homework or your exams, but you need to understand how that works. And all that effort that a student is willing to put into Calculus 1 will then make Calculus 2, differential equations, and Calculus 3 considerably easier because you'll start to see those patterns. And what's initially maybe like vocabulary words in a foreign language, then growing into sentences and paragraphs. That's the same thing with math. You start off with what would be vocabulary words, growing into equations, right? Then growing into even larger pieces that tell a story. Because at the end of the day, every math equation, every engineering equation, every physical and chemical equation is telling us a definitive story, and we can only understand that if we approach it with the same enthusiasm for study as we would a foreign language or music or a physical skill. So for whatever reason, and I don't know why, we dismiss how much work it actually takes to get up and running with our math. And yet, once we understand that math and that study process, it's actually kind of fun because unlike many other things we tackle, math problems work out. Physics problems work out. Engineering problems work out. We actually can get to an answer, and we don't get to say that about a lot of things in life. So certainly not in dealing with humans.
Yeah, that's for sure. That's for sure. So, Skylar, let's shift gears a little bit now and get into this idea of underground storage. So, what is underground storage and why is it essential for the future of energy infrastructure?
Sure. So I love what I do, and this, I have to tell you, came as a complete surprise to me. Until I got into this role, did not understand how important underground storage is for energy infrastructure, not only in the United States but around the globe. So we as a country use natural gas as one of our main energy sources, and I'll use that as an example because most people are familiar with it. Natural gas is pumped out of the ground and you put it in you'll have to clean it up and put it in a pipeline. And then what you end up doing is storing it either in a depleted oil and gas reservoir, a salt cavern, or maybe a saline aquifer. And you store it until you need it because in this country, as in most countries, it's cyclical. It's you produce it during the summer when you're not using as much, and then you inject it in the fall. And then in the winter, what you can do is withdraw it from storage so that you have it for either homes that are heated with natural gas or power plants that use it to generate electricity. Well, right now, we use a little under 10%. We store a little under 10% of our total usage for natural gas in this country. It's incredibly cheap because of how widely available it is, but it looks like with the increase in AI, data storage, technology, everything we're doing that's increasing the amount of electricity that we use on a day-to-day basis, this is all going to drive more natural gas production. And you need to have, just like we have a savings account for our own personal finances, right? Just to handle to serve as a buffer in case something large comes through, a large check comes through. We know we've always got a buffer of cash in our savings account. That's exactly what underground storage is. Now, what's so fascinating and where I ended up uniquely qualified for this because, again, I didn't plan on this job. Just like you were saying, you go out and you get the degrees and then you end up with these really cool positions that you never knew existed. Oil and gas comes out of a reservoir, right? That's porous media in the subsurface. But we can also store natural gas in that same reservoir. So you don't go put a tank in, you don't go line it. Same with a salt cavern. You use fresh water, you leach it, you create this cavity in a giant salt dome. And if you're wondering how big these cavities are, they can be on the order of the size of the Empire State Building. So when I say these
Whoa.
are enormous cavities in domes, these are enormous cavities. And so you can fill those. And our strategic petroleum reserve, that's where we store our nation's oil supply for an emergency. Again, that buffer, that savings account of crude oil. So we're seeing this all over, this interest increasing all over the country because it's recognized now that we have a driving need for electricity and energy. It's not going to stop. It's not going to get less. And so, what can we do as a country to ensure we have enough as a buffer for safety, right? A savings account, and still increase the volume that we're using. And that's going to be in underground storage.
Wow, so these can be natural?
They're all
Like
natural.
natural?
They're
They're
all
all
natural.
natural.
Yep,
Hmm.
everything I do is in a geologic formation. There are no tanks underground in the work that I do, and the reason is because the volumes are so massive, it would be cost prohibitive to dig out and build a
Right.
develop a tank. And also the rock that we use, salt is impermeable. We know oil and gas reservoirs are an effective trap because they've been trapping oil and gas for millennia, millions of years actually. And then saline aquifers, same story. Those are typically a little bit deeper and are millions and millions of years old. So all three of those are very effective storage mechanisms. The fourth one we do that's more up in your neck of the woods, hard rock caverns. Those are also very effective. They just tend to be a little more expensive because you're actually mining out hard rock before you store liquid petroleum gases. So those are going to be your propanes and your butanes. And those are also used for heating homes. But for what we're talking about for the energy infrastructure right now, natural gas is the one that has everybody's attention. 4 years ago, it was hydrogen, and we can store hydrogen in salt caverns. We do that right now. And then there are a couple of studies going on, one with the Gas Technology Institute. They're studying depleted oil and gas reservoirs for hydrogen storage. And then the National Energy Technology Laboratory out of Morgantown, West Virginia, is studying bedded salt for hydrogen storage. So salt comes in basically two forms, for lack of a better complicated answer. One is
Okay.
chromal, and those are going to be on your American Gulf Coast region. Those are those great big sort of lava lamp, if you can envision those, coming up through the Earth's surface, domal
Yep.
salts. And then the bedded salts are going to be more up along the Rocky Mountain range, and then over sort of in Ohio, Michigan area. And those make little shorter salt caverns. Those are little flatter ones. So you have to make more to get the same volume, but they're just as effective.
Interesting. So my follow-up question based on that would be, being that these are natural caverns and cavities, what role does subsurface engineering play in these energy storage solutions? And, how does that intersect with geotech and civil engineering?
So the caverns are man-made in the naturally occurring salt. So that's my job, is to get my technical engineers, subsurface engineers, cavern engineers paired up with what the company is trying to accomplish. So we'll just keep it straightforward. We'll just do a salt dome. So that's a great big one, right, in Texas, Louisiana. You'll have a petroleum engineering type drill in, right? Just a regular heavy duty drilling rig. You drill into the salt. You case it like you would just about any upstream well and well bore. They take off, and then you've got two hanging strings in there and a specialty wellhead sitting on top. You pump in water and fresh water in one hanging string, and then you return it through the other hanging string, and then you send that brine either to a saltwater disposal well or a brine pond. And you do this for 1.5 to 3 years to get this nice sized cavity in the salt to hold whatever it is you want it to hold.
Wow, that's wild.
So that's
That is.
where somebody like my job would be, if I weren't always outward facing, that would be something that I would do, is help design those and run those programs. For the surface work, then the civil engineering, and what more your discipline would be useful and help with, is that's everything I do is subsurface. But on the surface, of course, you need to have you need to have infrastructure. You need to have pipelines, right, that can get the brine initially from the cavern out to where you're disposing of it. But then you're also going to have, when you're storing natural gas or liquid petroleum gases, you're going to have pipelines coming in. You're going to have compressors. You're going to have delivery pipelines. You'll need administrative buildings, roads, high voltage electricity,
So there's a lot of other engineering
all
coming into play
right.
there.
And the reason I'm speaking so vaguely on all of that is because I don't do any of that.
Right, but I mean, but the project itself is going to call for a lot of different engineering specialties, essentially. And I guess one question I would have for you, just big picture for some context, is, as an example, like if your company, let's say, WSP is working on a project, would it be something like the government would call them, or a utility company would call them and say, "Hey, listen, we need to store a bunch of gas. How can you help us do that?" Like, what's the context of how you get hired to do this?
Sure. So, one of the neat things about my group is we are overwhelmingly hired by private industry. So, this is going to be your midstream companies. It'll be like your Williams, your Targa, your Enterprise Products Company, Enbridge. Those are some of the big names that you might know. But midstream companies aren't as well known because we know the drilling, the sexy upstream drilling, wildcatting, right? It could be, those names are going to be like BP, Shell, Exxon. Those are the majors. They pretty much handle all of their own drilling and all of their own storage, but those would be upstream names in the petroleum world. And then downstream, of course, that's your refining and your retail sales. And so, again, those would all be names you're familiar with, maybe Conoco, Marathon, again, Exxon, Shell, BP. Okay. But in the middle, what connects getting the oil and natural gas out of the ground with your utility companies or your local distribution companies is the piece that's called midstream, and that's all storage and transportation. And so what we do is really B2B. We don't often interact with just everyday customers, because all of our work is we're helping get it from this one business, store it so they can deliver it to this next business. For, let's see, So that's one. And then you asked about the government. So, for example, we have done work for the Strategic Petroleum Reserve. We just put in 2 monitoring and observation wells that they're using for study. And the national lab that works most often with the SPR is going to be Sandia National Lab out of New Mexico. And so we were hired to go in and just put observation wells in so that they can see how the salt is behaving and what the stresses are doing and what that means for storage. For utility companies, the one that we would that might be known, and they're out of Texas, is Atmos. And so we do their salt cavern work. We've done a lot of great salt cavern work for them. But overwhelmingly, we do private companies. Your Phillips 66, Marathon was one. Those are more of the companies that we work with because their job is to be that middle piece connecting upstream and downstream.
Wow, that's awesome. I mean, I'm asking just because I mean I've done 1,000 podcast interviews and I've never heard of this aspect of engineering, which is wild. Which is just speaks to the fact that there's so many different opportunities in the world of engineering that you can get involved with. And these sound like exciting projects in that they require a lot of different engineering
Yes.
disciplines to
Yes.
get this done, which is great in terms of collaboration, project management, people working together, which is great. So, all right, I mean, I could ask Scyller a million more questions, but I'm going to take a break and we're going to come back and we're going to wrap up by putting her on our career hot seat. All right, we are back with Scyller Borglum, PhD, VP of Underground Storage and Energy at WSP USA, and author of STEM Study Habits. Skylar's taken us into the interesting world of kind of geological engineering, and we've talked a lot about these natural caverns, which she's got me fascinated. I'll probably go on Amazon and buy 10 books when we hang up. But now we're going to just kind of wrap up for today with a couple of career hot seat. This is our civil engineering career hot seat. We know that obviously, Skylar's working in petroleum engineering, but she's had a pretty fascinating career. So I think we'll get some interesting thoughts from her. So Scyller, first question for you here. Do you have any specific rituals that you practice every day, whether it's a morning routine or a lunchtime routine, or just something that you do consistently on a daily basis that has contributed to your success?
Absolutely. I start my day the night before. And what I mean by that is I am militant about getting really good sleep. I like to know before I go to bed what the day looks like the very next day. So I just do a quick look over my calendar. I also have recently started putting my phone in a different room so that I'm not tempted to scroll before bedtime. And I like to read a little bit before I go to bed. When I wake up in the morning, I rarely need an alarm clock because I go to bed consistently. So I get up, I press go on the coffee maker, I take my morning vitamins, I do my Duolingo, I read a chapter in a book, I do my Bible study, I hit the gym, and I'm ready for the day.
Wow. I would say you've definitely have a routine. That's great. You're the perfect person to ask that question. No, that's great. I mean, listen, like I said, and I said it before, and I'll probably say it a million more times on these episodes. It's all about daily habits, and we have to have, I think it's great to have, I'm not saying you have to be a robot, but I think I have the same thing as you, a very good morning routine, because that gets you set every day. That prepares you for the day. And that's a great way to kind of get yourself going.
Absolutely.
All right. So I don't know throughout your career whether there's been a book or an author or a philosophy or something that you've run into that has kind of stuck with you, that you've kind of used in your career and in your different activities that you've done. Is there anything like that that has stuck with you?
So the one that really stands out, I read when actually it was right after I was laid off. And I, just so you know, in here, I have a list of about 60 books that all meant
Oh,
something
wow.
to me.
Great.
So there's really good list of mentors, if you will, in the terms of authors. But the one that really stood out to me of all things was Arnold Schwarzenegger's biography or memoir, Total Recall: My Unbelievably True Life Story. And the reason is because he came into it talks about his how he became a bodybuilder and what he was doing in the military in Austria as a very young man, and then how he came to the United States of America with hardly any English, and he was told right up front His name is too long. He can't be an actor. That he needs to change it. Nobody's going to be able to spell it. He was told his accent was too thick. Nobody's going to want to listen to him. I mean, he didn't even have a college education. And so here was
Right.
somebody who through sheer force of will and good habits and character built an incredible life for himself in America. And so I read that at a time when I really needed to just get up off the couch, stop feeling sorry for myself because I'd lost my job, and it worked. And so for me, I recommend that book to just about everybody. And the other reason is because he's not a native English speaker, and that book was written, I would say, between the 6th and the 8th grade level, and it showed me how you can have these incredible and very powerful ideas, and if you communicate them in a way that everybody can understand, your idea will get out there. And so often in academia, I've seen, and I've been guilty of it myself, this really erudite, dense writing that you have to read one paragraph 3 times to understand what it's saying. His book, you can just read it. It's got great information in it, and you can go. And so for me, I bet I read that. I read that book over 10 years ago, and I still reference it today.
That's great. That's awesome. I want to check that out. All right. So the next question is thinking back on some of your managers of the past. You don't have to name names specifically, but we're just who was maybe when you think of your favorite or your favorite managers, what made them your favorite? Like we're just looking for characteristics or traits of managers in the industry that, do really well.
The best management trait, there are two. I'm going to say there are two management traits, especially at this point in my career. I can figure just about everything out that I need to now on my own for the work that I need to do. But what I need are number one, I need a decision. And I don't care if I like the decision, I don't care if I agree with the decision, but when I come to a manager or a leader and I'm asking, do you want me to attend this conference or not? Do you want me to do this project or not? I just need you to give me an answer, because after that answer comes a whole cascade of other things that I will need to
Right.
either be responsible for or not. And if I can't get an answer, then that means I'm stuck in limbo, which means I'm useless. And so for me, the best managers that I work with are the ones, or leaders in a company, they will give you an answer, they will give you a decision, and then you can go. And again, whether I like it or not, in many ways is secondary, but I just need to know, because my whole day is governed by what am I going to be doing? And if I don't know what I'm doing because my manager won't give me a decision, I'm useless, and they're paying me.
So not being a bottleneck, right? Like not like don't be a bottleneck for your
Absolutely.
team. Be
Absolutely.
able to give them the information they need so they can start working on it, and instead of it sitting there on the shelf, so to
Yep.
speak.
And then the other one, because I've had both ends of the spectrum on the second one, and that is treat people with kindness and give people the benefit of the doubt. So I have managers right now, that's what they do and that's how they operate. I have one in the past who was all the way on the other end of the spectrum, and it was in a totally different lifetime, and he actually sowed seeds of rivalry and dissent, or he tried to, in the team. And I've seen how destructive that is, and I can tell you I would so rather work for somebody on this end, and would work for somebody on this end, than I would all the way on that other end. So for me personally, those are the two most critical components for good management. One, make a decision. Two, treat people with kindness and give people the benefit of the doubt. Those two things.
That's great. All right, the last question I have for you, we call it our career elevator advice question. So if you got into an elevator with, let's say, an up and coming engineer, and you had 30 seconds with that person to tell them from your career just some advice that they should, implore or engage or act on in their career, what would you tell them in a very short period of time?
Make connections and friends far and wide in your company. So not just directly up your food chain, but reach out to people, set virtual coffee dates. We're now all accustomed to Teams and Zoom and a variety of different platforms. Get on people's calendars, introduce yourself, find out what they're doing, find out what made their career. And you never know who's either A, going to save your neck if the chopping block is there for layoffs, which happens, it's real life, or they may have you in mind for some other really cool position that they haven't totally defined, but they need someone with your personality quirks to fill it, then you'll be top of mind. So for me, I would say my 30-second elevator recommendation would be make friends, contacts, and connections widely all over your company, whether they're in your chain of command or not, and make sure people know who you are.
That's great. Well, Scyller, thank you so much for spending some time with us on the Civil Engineering Podcast. Where can our listeners find you, connect with you, find your book?
So
LinkedIn, I guess?
by
Or...
all means on LinkedIn, yes. I try very hard to respond within a day on all LinkedIn messages. My book is available on just about every online application. So whether you use Thrift Books or Amazon or a number of it's available around the globe. So I'm sure, Anthony, you've got a global listening audience. I had somebody download it in India. So it's available either through ebook or in print around the globe. And I will ask, if you do download it and read it or buy it and read it, if you would leave a review. I would also appreciate that, because it turns out reviews are the new currency for authors.
That I can attest to. So that's great. And again, you can connect with Scyller on LinkedIn, and her book is STEM Study Habits: Successfully Navigate Math, Science, Engineering, and Life for Your Degree. And if you connect with her on LinkedIn, she actually has the QR code right on her page as well to get you to the book as well. So once again, Scyller, thank you so much for spending time with us. It was a pleasure to talk with you
Anthony,
today.
the pleasure's all mine. Thank you so much.
I hope you enjoyed my conversation with Scyller. The stuff she's doing with the underground energy storage is really amazing, and I'm excited to learn more about it myself. And if you enjoyed this video, please subscribe to our channel here. We do put out videos like this on a weekly basis to help engineers become better managers and leaders. I'll see you next week.